anode physically expands during the charging and discharging cycles. This takes place because of the lithiation and delithiation processes that take place. So when you have charging, the lithium ions migrate towards the anode, and the anode becomes bigger in size. So volumetrically, it increases in size. So what happens in the existing lithium-ion batteries that you have in your cell phones or you have in your laptops is that they charge really slowly and they discharge equally slowly. So they do this because when the charging cycle and discharging cycle is happening, you have stress induced in the lithium-ion battery because of this volumetric expansion and compression that you have. So this basic structure here involves 3 different elements at the anode of the lithium-ion battery. So you have a gradient in the stress which gets formed because of this. So the silicon expands much more than the aluminum, which expands lesser than the carbon nanorods. So because of that, you can charge these systems faster and you can discharge them equally faster, so you can get higher acceleration out of the car. So this car can go up to 0 to 100 in about 3.9 seconds. This is possible only because of this really fast discharge that you get. So you generate your 500 horsepower because of that. And the third really important issue that I want to talk about is safety. So this is not related to these 2 topics, but it's completely different. So it talks about safety in Formula 1. Everyone's familiar with Formula 1, right? It's the motorsport of Europe. Like you have NASCAR in the US, you have Formula 1 in Europe. So you basically have these helmets in Formula 1 which are made from using, the outer structure is made from carbon nanofibers and Kevlar, and the inner structure is made by polystyrene foam. So I'm just going to show you a video of a particular Formula 1 crash.
Montoya was penalised last year for that. There was, that's a big accident. Or Kubica.
This is Robert Kubica.
Going on there. He's moving his hands, and obviously safety car will be out again. But he must have tackled with somebody in the braking area down there into, I think it's turn 10, into the hairpin. Kubica then, a lot of energy going on in that impact. Oh yes, he's had an accident very early on.
So what happens is that there's another car at that particular turn which collided with him, and because of that he lost control of his car, and it diverted, you can say, the top. It went in the air and it hit this wall here really fast, and he was traveling at about 185 miles an hour at that particular crash point. And if you observe his head when the crash happened, the car kept rolling on, so he experienced really extreme G-forces in the car when that happened, and when the car hit the wall, his head literally toppled this way and that way. So the helmet, basically the carbon nanofibers that were present in the helmet prevented him from getting a neck trauma. So how do you get a neck trauma? You have died like instantly. So this is basically the practical use of carbon nanofibers in those compound helmets.
Alright, as you can see, hope you're still following, because those fancy things about cars, not really some girly things. And as the only girl in this group, I'm going to talk about some applications of nanomaterials in health and beauty areas. Alright, so the fancy pictures you see here is the nanoparticles. So nowadays, fast detection of biological molecules at low concentrations is of great importance to early diagnosis and successful treatments for some diseases. Just imagine during the outbreak of some disease like SARS, it may take some days or at least several hours to diagnose the disease. And during that period of time, people may lose the best time for treatment and may lose their life. Meanwhile, the traditional methods we use to diagnose disease usually demands for a large amount of samples, which may lead to physical damage or pain for the patient. Biosensor based on nanomaterials, however, it has unparalleled sensitivity and specificity and rapidity, so that it can really tell you what kind of signal you are trying to catch within a very short time and at very low concentrations. The picture here is a SEM image of a biosensor. It is digitally colored and enhanced afterwards. It is a biosensor based on nanowires and anchored with gold-coated nanocubes. It is a blood glucose sensor. You may now be wondering how this kind of biosensor be made and how it works. So the schematics here shows you the cross-sections of biosensors and corresponding field emission electronic scanning microscope images of different fabricating steps. So basically, single wall cover nanotubes are grown from the pores of the bulk materials, which is a polymer here, and then lead nanowires and nanocubes are grown on the bottom and on the surface. And then these cubes are coated with a thin layer of gold. Okay, so this is how this kind of biosensors are made. So what happens when we try to detect the signals? The picture here shows you the basic steps. So basically, we link specific enzymes on the top of the biosensor. So when the glucose, which is your target, you want to detect during this process, is attached here. Some biological reactions happen which can generate electric signals and detected by the nanowires. And with this kind of facility, we are now able to diagnose disease within shorter time, which may save a lot of lives in the future. All right, so now we have healthy body with biosensor, and let's move on another part, which is nanomaterials applications in cosmetics. I remember once we were talking about how nanomaterials are applied in cosmetics. Here is an example. As we know that ultraviolet radiations is only a very small amount of all the radiations reach the Earth's surface. It's about 5% only. However, this kind of radiation is really harmful to our skin, and overexposure to that radiation can even cause skin cancer. Basically, the radiation are divided into two ranges. So one is from about 390 nanometers to about 320. And the other is from 320 to about 400 nanometers, which is the starting point of visible light. And the one from 209 to 320 is called UVB. It reaches the surface of the skin and may cause burning. And the radiation from 320 to 400 is called UVA, which goes deeper in your skin and may cause aging of the skin. So traditional sun protection use zinc oxide and titanium dioxide particles to screen the sunlight. However, this kind of particles are really too large, so that it cannot form transparent films in the sunscreen protection formulations, which is really a tragedy for people with darker skin tone. And by decreasing the size of the particles from over 500 nanometers to smaller than 200 nanometers, it can form transparent films so that everyone is happy and we can keep our skin from sunlight. All right, so this is all of our protection. As you can see here, nanomaterials are only mostly small part of all the products, but the size really matters. Thank you, and hope we have better applications in the future.